There are over 8 billion people on this planet, and if we hadn't discovered the right materials at the right time, that number might be half. In the early 1900s, the world faced a food crisis. Crops couldn't keep up with a growing population. Then came a breakthrough: synthetic fertilizer. Two brilliant minds, Bosch and Haber, discovered how to pull nitrogen from the air to feed the soil, but turning that discovery into something the world could actually use. That was thanks to Mitash. After 25,000 experiments, he found a simple, affordable material that made large-scale production possible. Without him, fertilizer might have stayed a lab experiment, not a solution that feeds billions today. From smelting copper to forging steel to etching silicon, materials have always been behind civilization's biggest leaps. No materials, no modern life. For most of history, we discovered these materials by accident, and through slow, painful trial and error. It took us millennia to go from stone to bronze to iron, centuries to go from alchemy to chemistry. But that's changing. Today, we have AI, we have robotics. We have the chance to explore billions of combinations faster than ever before. And we need that speed. Because while materials discovery has always shaped our future, now, the future is arriving faster than we can respond. Energy, health, climate. These challenges aren't waiting. The good news? AI can now simulate what an ideal material might look like on the computer. But here's the catch. We still don't know how to manufacture them reliably and fast enough for testing. When it comes to materials manufacturing, that data is a mess. It's buried in papers that focus on the end result, not the steps it took to get there. It's hidden in the industry or buried in confusing supplementary files. It's missing entirely when experiments fail, even though those failures are critical to learning. That's why we're building the Materials Data Factory, to generate the world's largest open dataset of how materials are manufactured, capturing not just what was made, but how it was made and failed to be made, with enough detail to train next-generation AI models. Imagine starting with a design target and instantly getting a reliable step-by-step recipe to manufacture it. You'd know whether a material is actually scalable for manufacturing before touching a beaker, including whether it can be produced using existing infrastructure and supply chains without major disruptions. This could significantly cut cost, risk, and wasted effort. And this power could be in the hands of every researcher, every startup, anywhere, where unexpected breakthroughs often happen. That's how we create a true multiplier for innovation, by providing tools that de-risk, democratize, and accelerate the path from concept to manufacturable reality.
The proposed element should serve as a viable replacement for palladium.
Thanks, Dan.
Unfortunately, it is impossible to synthesize.
Uh-huh.